New images from NASA's Hubble Space Telescope show how a nearby swollen star uses the remains of a dead star to revive the dying star. The legendary observatory has been monitoring the double star system some 700 light-years away from Earth for 30 years. He observes how the system dims and brightens as a result of the powerful pulses caused by its main star. The duo of white dwarf and red giant stars have a chaotic relationship. The duo that emits glowing gas into space is quite interesting. Astronomers call this duo, located in the Aquarius constellation, a stellar volcano because the duo emits glowing gas over an area of 400 billion kilometers. For comparison, this distance is 24 times larger than the diameter of the solar system. NASA is tracking how these stars recycle elements through nuclear energy. A statement from NASA says about the stars, "Plasma is hurtling into space at more than 1.6 million kilometers per hour, fast enough to travel from Earth to the Moon in 15 minutes. The filaments shine invisible light because they are energized by the bubbling radiation from the star binary. If a white dwarf star is in close orbit with a red giant star, it draws hydrogen from it." Image NASA Goddard illustration. The binary star system, known as R Aquarii, is a special type of binary star system closest to Earth called symbiotic. In this system, a swollen and dying old red giant and the shrunken core of a medium-sized star orbit each other. The massive star is more than 400 times more massive than the Sun, and its brightness varied greatly over a 400-day period. At its peak, the red giant was 5,000 times brighter than the Sun. Like this massive star in R Aquarii, our Sun is expected to turn into a red giant in about 5 billion years. As the white dwarf in R Aquarii approaches its massive companion during its 44-year orbit, the dead star gravitationally steals stellar material, causing hydrogen gas to accumulate on its cold surface. This process causes the star to sort of resurrect, heat up, and eventually ignite like a bomb. NASA and the European Space Agency created the time-lapse video above using photos Hubble took of R Aquarii from 2014 to 2023. This thermonuclear explosion is called nova. Do not be confused with the name supernova, which is given to the destruction of a massive star before turning into a black hole or neutron star. The nova does not destroy the white dwarf. Instead, the explosion causes elements such as carbon, nitrogen, oxygen, and iron to be scattered into space. This year, scientists are eagerly awaiting a nova from T Coronae Borealis, or T or B, a binary star system located about 3,000 light-years away in the Milky Way. This special nova, which can be seen with the naked eye, is interesting because it experiences periodic explosions. Experts have determined that this star explodes approximately every 80 years. A few months ago, experts expected the white dwarf to turn into a nova before September. However, interestingly, this sudden flash did not occur. Repeating novae are unpredictable and outlandish, NASA astrophysicist Koji Mukai said in a statement in June. Just when you think there cannot be a reason why they follow a particular pattern, they do. And as soon as you start relying on them, repeating the same pattern, they go completely off. It is very important to understand these events, because this event is of great importance in terms of producing and distributing the materials necessary for new stars, planets, and life. This is exactly what astronomer Carl Sagan meant when he said that humans are made of star stuff. The same substances that make up our bodies are literally forged in the cores of stars, then flung across the cosmos when the stars explode. R Aquarii spews glowing jets that bend up and out following strong magnetic fields. The plasma turns on itself, forming an enormous spiral